Okay, we have 2.5, we have 2.6. 2.5 will not take us long to get through. This is really a one-day, two-day topic, continuity, and this is a topic. Really, you're not going to use this much again unless you take an analysis course, but this is definitely a topic for calculus. Continuity is extremely important. In fact, calculus requires that you have some things that are going to be true all the time. And one thing is, in order to apply calculus most of the time, you have to have what we call a continuous function. So a function f is said to be continuous at a number a, so I'll maybe put quotes around this, at a number a, if the limit is x approaches a of f of x is equal to what we say is f of a. So meaning you could just take that number and plug it in and get something. But this assumes that there's a few things that are true, okay? And number one, we need to state this, okay? So these are the three conditions that continuity has to satisfy, or that a function has to satisfy in order to be continuous. Number one is this. F of a by must exist. The shorthand definition for continuity is this. I can draw the function without picking up my pen. You know, that's the real, I mean, mathematics hates those type of things. It's like, well, that's not a definition. That's the way you explain it to your, baby brother, Like when I go home and Kira says, what'd you do? So yesterday I went home and Kira said, she said, Daddy, what'd you do today? I said, well, we proved that the limit exists of a function at a given point. I said, it was pretty cool. She says, oh. And I said, what'd you do today? She said, well, we proved we could stay quiet as a class for 2 minutes straight. And so that, yeah, exactly. I was like, okay, cool. We're both in the proving realm, and that's where we're at. So anyway, but that's Kira doesn't understand what that means, but she would understand to draw something without picking up your pencil, and that's what this means. So in order for those things to be true, f of a, the output must exist. You can't have a dot, an open circle spot there. Also, the limit as x approaches a of f of x. So the limit must exist. And then finally, the third piece. 1 and 2 must be the same. So the limit as x approaches a of the function must be the same as f of a, which is what we stated in the beginning. So the idea is, now that we've said a limit exists, let's show that it carries forward through the function for all the values of the function. It's continuous all the way through. So let's look at some great examples. These are classic examples. I did many of these in my, they are. Using the graph at the right, identify the numbers for which f of x is discontinuous. Identify which of the three requirements it fails to meet. Finally, identify the intervals for which f of x is continuous. So let's look at this here. Discontinuous is somewhere where you would have had to pick up your pencil in order to then draw the function. So can you identify an x value where it's discontinuous? -5 would be 1. Okay, so I'll write that one down. Got another one? 1 and 4. Those are the three x values. So this is another thing you'll be expected to do on your test is, number one, identify where it's discontinuous, where you would have to pick up your pencil, okay? So I'm going to start with 4, okay? I'm going to start looking at 4 just because I want the sequence to follow correctly. Let's look at this. For number 4, does f of 4, if I plug in 4, do I get an output? No. So it fails to meet requirement 1, meaning f of 4 does not exist. And you could even say, fails, requirement 1. Either one would be fine. You could just say fails number 1, or you could say f of 4 does not exist, saying the same thing. Okay? So we know it's discontinuous for that reason. How about at 1? If I plug in 1, do I get an output? What is the output? So good, we met the first criteria. Okay, let's look at the second criteria. Does the limit as x approaches 1 exist? Why not? Because the left hand is not the same as the right hand. The left hand limit approaches -3. The right hand limit approaches +4. Those are not the same. So therefore, 1 fails because the limit as x approaches 1 of the function does not exist. Or in other words, it fails requirement 2. So this is the third situation. So do you understand the difference between those? Here you have an open spot. Here you actually fill it, but the limit doesn't exist there. So let's go to the last situation. Does f of -5 exist? What's the value? Yep, the value is 3. So f of a exists. F of -5 exists. Does the limit as x approach -5 exist? Yes, what is the limit? It is 7. Is the limit the same as the output of the function? No. So you would say the limit as x approaches -5 is equal to 7. And right, that's what I'm going to do here. And the other part we would say is f of a, or f of -5, you said is equal to 3. And those are not the same. So I'm not going to get real critical on how you express those. You could just say that, the limit as x approaches 5 does not equal f of -5. That will be fine as well. Okay? But that's the idea, that those are different values. What do you think? Easy enough? Okay. So it says, use the definition of continuity and the properties of limits to show that the function is continuous. Oh, I forgot to give the intervals of continuity. I'm sorry. The last part says, I always forget to do this, and you get in your assignment, you wonder what you're supposed to do. Finally, identify the intervals for which f of x is continuous. Okay? So, there's no closed dot on the end of here. There's no ending, so I'm not going to include that. I'm going to go from -7 to what? -5. Can I include -5? No. After that, -5 to 1. And then 1 to 4. 4 to 6. We just don't know if the graph really goes on. We don't really know that for sure. Now, I'm going to change this for a second. If we say put a circle in there, and that was that, is it now continuous? No, it's still not continuous. However, this would change in that I would put a bracket around like that. Okay? All right? Okay. You know what? We only have 10 minutes. Let's just do a couple problems in our assignment based on just this idea first. Okay? So let me give you those type of problems to work on, and then we could get through the rest tomorrow, and we'll end at a good spot for Friday. So we are already through. Tomorrow we'll finish 2.5. We only have to get through 2.6, so we might be able to have a test at the end of next week. So. So what I'd like you to do is A, do problems 3 and 4 on page 110, and B, you need to start working towards memorizing the precise definitional limit and the definition for continuity. So for your test, the continuity one we just put forth. That's pretty, I think it's pretty easy. You need to know those 3 criteria. F of A must exist. The limit as x approaches A of f of x must exist. And those first 2 must be equal to each other. They must be the same. So, so you got a light homework assignment, but let's make sure that we also look at that. And then tomorrow we'll give you a little bit bigger of an assignment for the weekend because I know you need work to do. So, all right, great times. Bye, Elizabeth. We know you're gonna be watching. Anybody else want to say hi to Elizabeth? No, nobody. Oh, Emma does. Emma has a good heart.
Hey, try hard, buddy.
Whoa, all right. You want to say hi? What would you like to say, Elizabeth, Larry?
You still owe me $5.
What's up, $5? Whoa. Hey, Elizabeth, I got a message for you. Do your homework. Don't do drugs. Stay cool.